Hi everyone. So today we're gonna solve. My name is Ajar Yaskinir, and today we're gonna solve a few problems related to chapter 5. First is 5.7 exercise and problem 5.2. So um, let's start. 5.7. Jose Garcia's lifelong dream is to own his own fishing boat to use in his retirement. Jose has recently come to an inheritance of 400,000. He estimates that the boat he wants will cost 300,000 when he retires in 5 years. How much of his inheritance must he invest at an annual rate of 8% compounded annually to buy the boat at retirement? Okay, so what do we have? We have 5 years, and at the end of those 5 years, future value must be 300,000. So let's write down future value 300,000. Uh, Interest rate is 8%, and number of years is 5. We have a formula that present value equals to future value multiplied by present value interest factor. What is present value interest factor? Present value interest factor we can. I'm so sorry. Number of years is 5. We can find it using a table. Where can you find? Using a couple of tables. You can find those tables, for example, on L Drive. You go to Ruslan Safarov, Alt, then Books, then a book called Sevens. And in the end of this book, you'll find the numerous tables like this, um, from which we will find our present value interest factor and future value interest factor. So what do we have here? We need to find present value. All right, so we're gonna use the second table, which is present value of $1. We have number of years is 5 and interest rate is 8. All right, 5 and 8. It's gonna be 0.68, 0.58. All right. Out of these two numbers, we've got that present value interest factor is 0.68, 0.58. All right. Let me change my comma. All right. So from now on, we can find a present value. All we need we found. So we're gonna just multiply future value by this present value interest factor. So here it is. Out of 400,000, he has to invest right now just 200,000, $4,174. That's all. Okay, I hope you've got this one, and we can move to problems a little bit harder. Okay, problem 5.2a. What is the amount of a payment that net Wellslow must make at the end of each of 8 years to accumulate a fund of 90,000 by the end of the 8th year if the fund earns 8% interest compounded annually? So here we have to deal with payments. Uh, it says that payments are made at the end of each year. What do we know about annuity? Annuity can be two types: ordinary and annuity due. Ordinary is when payments are made at the end of each period. Okay, end. And annuity due is when it's in the beginning. Beginning. This rule we have to keep in mind while solving. All right, so let's begin. A. What do we know? We know that our future value must be at the end 90,000. Future value is 90,000. All right. Our interest rate is 8%, and number of years is 8. Again, it says that must make the payments that a net must make at the end. At the end, it means that it is ordinary. Okay, let's write ordinary. And payments unknown. Payments we don't know. All right. Let's put it here. Payments unknown. So basically, we need to find payments. We have a formula for that. That future value equals to payment multiplied by future value interest factor. Future value factor. So from here, we can derive payment. Payment gonna be equal to future value divided by future value factor. Future value we already have, and future value factor we can find from these two guys by using again a table. What kind of table do we need to look at? It's future value ordinary annuity. I've got it somewhere here, future value ordinary annuity. We have 8 number of years and 8%. So we have to use this number, 10.6366. I hope you see it. 10.6366. All right, let's write it down. So our future value interest factor gonna be 10.6366 payment. So payment here will be equal to future value divided by future value interest factor. Future value interest factor. So that's it. This is our payment that he has to pay over 8 years at the end of each year. Okay, now we can move on to our B. Yeah, let's read it. Robert Hitchcock is his 40 years old today, and he wishes to accumulate 500,000 by his 65th birthday, so he can retire to his summer place on lake. Okay, so again, already from this information, we can see and derive that a number of years will be 25. Okay, let's move on. He wishes to accumulate his amount by making equal deposit on his fourth through his 64th birthday. What annual deposit must Robert make if the fund will earn 12% interest compounded annually? Here we have to deal with annuity due. So future value is 500,000. Again, number of years is 25. And interest rate is 12%. All right. What do we need to find? We need to find, again, payment. Payment is unknown. And we have annuity due. Annuity due. All right. Again, we're gonna use here a formula of future value. Payment equal to future value divided by future value interest factor. Interest factor we're gonna derive by using this information, but using a table of annuity due. So here is future value of ordinary. It's not okay. Here is the thing we need. Future value of annuity due. Okay, 25 years and 12%. 25 years and 12%. 12%. So it's gonna be 149.3339. All right. Future value. Interest factor is 149.3339. So payment gonna be 500,000 divided by this factor. So here is an equal payment that he has to make each year to receive 500,000 to accumulate. Super. Okay, let's move on to C. Diane Ross has 20,000 to invest today at 9% to pay a debt of 47,347 dollars. How many years will it take her to accumulate enough to liquidate the debt? Okay, so there are no payments. All right. What do we have? We have present value of 20,000. All right. What else we have? We have an interest rate of 9%, 9%, and a future value, 47,347. All right. A number of years are unknown. Number of years is unknown. All right. We have a formula again that future value equals to present value multiplied by future value interest factor. Future value interest factor. From here, from this formula, we can derive future value interest factor because we know that it contains number of years and interest rate. Interest rate we have, but we don't have a number of years. So later you will see how I will find it. Okay, future value interest factor equals to future value divided by present value. Present value. Okay, good. Uh, so we can find a number. Future value divided by present value. So here is our future value interest factor. What we can do, we can look at table 1. And as already we know the interest rate, we can find a number of years easily. Let me show you how I'll do this. We open table 1, future value over $1. Interest rate is 9%. 9%. So we're gonna use this table. And our number, our factor is 2.36. It's somewhere here, 2.36, 735, 736 we've got, but it's super close. And a number of years is 10. So that's it. From here we can write like from table 1, number of years is 10. Is 10? 10 years. That's the answer. It's easy, isn't it? Okay, so D. Cindy Houston has a 27,600 debt that she wishes to repay 4 years from today. Okay, from today. She has $19,553 that she intends to invest for the 4 years. What rate of interest will she need to earn annually in order to accumulate enough to pay the debt? Okay, so what do we have? We have a number of years. 4. What else we've got? We have a present value. Right now she has 27,000. Oh no. Right now she has 19,000. 19,553. And the future value of 27,600. What do I need to find? We need to find a rate. Rate. Rate is unknown. Rate is unknown. We have a formula. Again, future value equal to present value multiplied by future value interest factor. And we can derive future value interest factor. Future value interest factor equals to future value divided by present value. All right, so future value divided by present value. So here it is, future value interest factor. Again, I'm gonna use a table 1. We've got an answer, we've got the number of years, and all we have to find is a rate. Let's open table number 1. So our answer is somewhere here, and our rate, and our number of years is 4. Let's see, 4. So Let's find from this line, our answer. Our answer is 1.411. 1.411. So it's here, super close. 1.411, 5/8 we've got. It's super close. All right. So our rate is 9%. 9%. We can write again, like from table 1, R is 9%. That's all. That's all. I hope you liked it. So if you need to find those tables, again, you can find it on L Drive. They're pretty helpful. And I think that's all you need for fifth chapter. I hope you liked it. Bye.